Hello everyone, welcome back to my YouTube channel. I am Nihar, studying in Sri Venkateswara College of Engineering, Bangalore, in the Department of CSE Cybersecurity. Today I am going to explain you about theory of computation, how a DFA string works, how a DFA processes its strings. Now let us see the introduction for DFA first. A deterministic finite automation is called DFA. Full form of DFA is a theoretical model of computation. It consists of states, transitions, and initial states and accepting states. DFAs are used to recognize patterns within their input strings. The components of DFA. What are the different components present in DFA? A DFA is defined by 5 tuple. Q represents a finite set of states, while sigma is the input alphabet. Delta is a transition function, Q naught is the initial state, and F is a set of accepting states. As you can see on the right hand side, there is a simple example of DFA. The state set Q. The state set includes all possible configurations of the DFA. Each state represents a specific condition in process in the input string. The number of states can vary depending on the complexity of the language. The input alphabet sigma. The input alphabet is a finite set of symbols that a DFA can process. Each symbol in the alphabet influences the transitions between the states. The choice of an alphabet affects the language that the DFA can recognize. You can see there are four inputs given. First one is match one or more instances of any word character that we use an hyphen or a comma, useful for finding email usernames. Next, the symbol is at that match the at sign, at the rate of. Next one is capture one or more instance of any word character followed by a comma, useful for finding mail servers, Gmail, or an HR company. And last one is match between 2 and 4 instances of any of the word character, useful for finding domains like com or ph. Now let us come to the next, the transition function. The transition function defines how the DFA moves from one state to another state. It is a mapping from one state. It is a mapping from the Cartesian product of Q and sigma to Q. Each input symbol leads to a deterministic next state. The initial state Q naught. The initial state is also called the starting stage. The initial state is where the DFA begins to process the input strings. It is a specific state from the queue and it is crucial for starting the computation. The initial state is denoted as Q naught in the DFA definition. As you can see in the right hand side, the diagram is a transition diagram where Q naught is the starting state and Q4 is the final state. Accepting states F. Accepting states determine whether the input string is accepted or rejected. A string is accepted if the DFA ends in one of these states after processing. The set F is a subset of Q and its configurations affects the DFA's behavior. Now let us see how an DFA processing an input string. The DFA processes an input string symbol by symbol starting from the initial state. For each input symbol, it uses the transition function to determine its next state. This process continues until all the symbols in the string have been consumed. Example of string processing. Consider a simple DFA that recognizes the string AB in the given example at the right hand side. Starting in the initial state, the DFA removes to move to a new state after reading A. It transitions to accept the state after reading B, thus accepting AB. Rejection of strings. A string is rejected if the DFA ends in a non-accepting state after processing. For example, if the input is AA and the DFA is designed to accept AB, it will reject. The DFA structure determines the conditions under which strings are accepted or rejected. Determinism in DFA. In DFA is deterministic meaning for each state and input symbol. There is exactly one transition. This guarantees predictability in processing strings. Non-determinism, in contrast, allows multiple possible transitions, complicating string processing. Language recognition. DFS are used to recognize regular languages, which are a subset of formal languages. A language is regular if it can be represented by a DFA. DFS provide a systematic way to classify and accept strings in these languages. Conclusion. DFAs are powerful tools for pattern recognizing and languages processing. Understanding how a DFA processes strings, it is fundamental for computer science. Their deterministic in nature and systematic approach make them essential in various applications. These are related to how a DFA processes strings. Thank you.